Hi everyone. Myself Harshita S. I'm currently pursuing my 6th SEM in Sri Venkateshwara College of Engineering. So my today's topic is all about the solar photovoltaic system. So individually we know what is solar energy. So any form of energy that will be derived by the sun will be known as solar energy, and the photovoltaic cell is nothing but solar cell, which is an electronic device that will convert the energy of the light directly into electricity by the photovoltaic effect. And let's see what is together the solar photovoltaic system. So, solar photovoltaic system is composed of one or more solar panels that will be combined with an inverter and other electrical and mechanical hardware that will use energy from the sun in order to generate the electricity. So, solar photovoltaic systems are considered as a promising renewable technology, and they are expanding rapidly in the recent years. So, based on the report that will be given by the the solar radiation PV installation in 2017, that is 99.1 GW, which is a gigawatt, is as much as cumulative installation in 2012 that is made 100.9 gigawatt, which resulted in a total global solar photovoltaic capacity over 400 gigawatt in 2017. So solar photovoltaic systems convert solar energy into direct current electricity using the solar cells, which are normally made by semiconducting materials. So common technologies that are used in PV industries will include the crystalline silicon, the thin film, and compound semiconductor and nanotechnology. So let's see what is this abstract of solar photovoltaic systems. So solar photovoltaic systems can be installed on a rooftop areas of residential, commercial, and industrial buildings. And here we can see the design aspects of a grid-tied solar photovoltaic system that will be presented in the next slides, and the applications, the benefits, and technical aspects of BIPV systems that will be discussed. And BIPV systems is nothing but building integrated photovoltaic systems, and the string inverter, the micro inverter, the DC optimizers of different manufacturers are also described, and the rooftop mounting methodology, including the east-west mounting, is also explained. The costing of the system has been done, and the life cycle cost and levelized cost of energy for a typical example of 52 kilowatt solar PV system has been estimated. So the reliability of the solar photovoltaic systems and the failure modes of solar models in the field will also be discussed. And the system issues like tripping of the inverter due to voltage rise issue, model failure due to the potential induced degradation, and fire and burning of modules are also discussed. So this is an basic structure of an solar photovoltaic on an grid systems. So what is a grid system? So grid system is nothing but it is an electricity generating solar photovoltaic power system that is connected to the electricity utility of the grid. So next. So here we can see the formation of an photovoltaic systems. So the solar cell will be connected to the solar module, and then it is connected to the solar panel, and then it is connected to the solar array. And this is an photovoltaic system. So basically what is a solar panel? So solar panel is a panel design that is used to observe the sun's rays as a source of energy for generalizing the electricity or heating. So advantages of solar panel is nothing but it is renewable clean source, and we'll individually see what are the components of this photovoltaic systems. So photovoltaic systems will include the electricity meter, AC isolator, fuse box, inverter, battery, charge controller, generation meter, DC isolator, cabling, mounting, and as well as tracking system. So we'll individually see what each of the components will perform. So first we'll see what will the electricity meter do. So electricity meter is nothing but it is a piece of equipment that will measure the amount of voltage that has been generated. Next, isolator. So we know AC isolator. We know what is AC. So it is an alternating current. And isolator is nothing but it's a mechanical switch device. Next is a fuse box. So fuse box is nothing but these are the metal boxes that will store the fuses, which is an electricity safety measure that will shut off the power when the power is beyond the measure. Next, we'll see what is our inverter. So we also know that inverter is also called as AC drives. So these are the electronic devices that will turn DC to AC. Next, battery. So battery is a source of electrical power which is consisting of one or more electrochemical cells with external connections. Next, the charge controller. So charge controller is nothing but it is an hardware or software device that is used to control the flow of electricity. Next, DC isolator. So DC is nothing but as a direct controller, and as we know, isolator is a mechanical switch. Next, what is cabling? So cabling is in building or in campus infrastructure, and it consists of in smaller elements called subsystems. Next, what is mounting? So mounting is basically called as solar module racking that are used to fix the solar panels on surfaces like roofs or the ground. Next, we'll see what is tracking system. So tracking system are also known as locating systems, which is used for observing of persons or objects on the move of supplying a timely ordered sequence of location data for the future processing. So these are the basic components that are used for formation of an photovoltaic system. Next, what are the application of photovoltaic? What are the applications of in solar photovoltaic systems? So solar photovoltaic systems can directly transform the solar light energy into electricity by photovoltaic effect. So an basic photovoltaic cell is essentially a diode which is made up of a p-type and n-type semiconductor. So we know what is a semiconductor. So semiconductor will partially allow the electricity to flow through it, and the types of semiconductors will be p-type and n-type. Next, the semiconductors can be processed to a crystalline structure that will be enabling the adjacent atoms to form the precise connections through each of their covalent electrons. Next, when these types are connected together, a space charge region is found at the interface where the neighboring extra charge carriers can move across these border to create a reverse direction electric field to impede further charge carriers movement. And when this PV cell is hit by the solar light, the electrons will gain enough energy to build the energy band gap, and the newly created charge carriers will be free to move under the built-in potential difference of the PN junction by giving the possibility for the external circuit to harness this resulting current. So the next generation technology we are enabling with the photovoltaic across a range of applications and locations have been described here. So in that, we are studying about the solar farms, the remote locations, the standalone power, the power in space, building related needs, military uses, etc. So we'll see what is the solar farms. So we can also consider these as some of the applications of the photovoltaic cells. So in that, first is our solar farms. So many acres of photovoltaic panels can provide the utility of scale power from tens of megawatts to more than a gigawatt of electricity. And these large systems, which are using the fixed or sun tracking panels, will feed the power into the municipal or regional grids. So next is our remote locations. So remote, we can usually think of something that is in rural areas. So we'll see what are in remote locations. So it is not always a cost-effective, convenient, or even possible to extend power lines to locations where electricity is needed. So PV can give this solution for the rural homes, villages in developing the nations, lighthouses, offshore, oil platforms, desalination of plants, and also the remote health clinics. Next, we'll study about the standalone power. So in urban or remote areas, so PV can power standalone devices, tools, and meters. So PV can also meet the need for electricity for parking the meters, temporary traffic signs, emergency phones, radio, transmitters, water irrigation pumps, stream flow gauges, remote guard post, lightning or roadways or more. So next is our power in space. So from the beginning, so photovoltaic cell has been a primary power source for Earth orbiting satellites. High efficiency PV has supplied power for ventures such as international space stations and server rovers on the moon and Mars, and it will continue to be the integrated part of space and planetary exploration. Next is building related needs. So in buildings, the photovoltaic panels mounted on roofs or ground can supply the electricity, and also the photovoltaic cell material can also be integrated into and building structures as windows, roof tiles, cladding to serve in dual purpose. In addition, avenues and parking structures can be covered with this photovoltaic cell to provide shading and power. So next is our military uses. So the extended version of photovoltaic cells is also used in militaries also. That is nothing but lightweight. It is flexible. It is a thin film photovoltaic cell which will serve applications, which is a portable and also it is a critical. So soldiers can carry the lightweight photovoltaic for charging electronic equipment in the field or at the remote bases. So let's see what the photovoltaic cells will do with these generators. So when power must always be available or when larger amounts of electricity than in photovoltaic system alone can supply are occasionally needed, an electric generator can work effectively with this photovoltaic system to supply the load. So during the daytime, the photovoltaic models will quietly supply daytime energy needs and also the charge batteries. And if these batteries will run low, the energy generated will run at in full power, and it is almost costless and it is a fuel efficient mode of operation until they are charged. And in some systems, the generator makes up the difference with the electrical demand and it will exceed the combined output of the PV modules and the batteries. So the electrical performance of a particular photovoltaic system was experimentally evaluated during a spring day in a Tunisian Saharan city, Toizer. And this solar system consists of 40 spaced solar cells, which is made up of CIGS and of cylindrical shapes. Due to its open design, this solar system allows the solar cells cooling by the natural ventilation. The measurements that have been taken for an horizontal and inclined panel and for a gray and white soil. So experimental results showed the advantage of the inclined system, which will collect the higher intensity of the solar radiation, which is resulting in the higher electrical production of the photovoltaic panel. So concerning with this effect of the nature of the soil on which the panel is placed, a higher declaration electrical production will be obtained for the white soil, which is unlike the gray one and allows the panel to operate with an additional part of the solar radiation that will be reflected by this particular soil. So here we can see a beautiful picture of a solar panel. And as I already discussed, a solar panel is a panel design that will be used to observe the sun rays as a source of energy for generating the electricity of heating. So what are the advantages of solar panel is nothing but it is a renewable clean source and it is scalable. It is a low maintenance of cost. And let us see what are the three types of solar panels. So the three types of solar panels are nothing but monocrystalline solar panel, polycrystalline solar panel, and thin film solar panels. So what are the uses of solar panels are nothing but, so it is used in solar electricity, solar water heating, and solar ventilation and solar lighting. So this is all about the solar photovoltaic systems. So thank you.